So I'm going just a couple minutes for people to join. And once you join, if you would please post a question on that's my right hand side. Maybe that, if you look at it from that way. Anyways, if you go on the Q&A app and post that, that would be great. I'm going to do a quick post to all the chemistry sections with the link just to remind everybody. Maybe everybody will do that then. So I'm posting it to Schoology, so hopefully everyone sees it there. And then once you guys get on, you need to type in some questions so that I can answer those questions. I will be happy to start off going through the essential skills, and I can go just 1, 2, 3, 4, and then I was going to do the lab question and maybe talk about a few things. Remember, every test now has review questions, so past units are in there as well. So I will maybe talk a little bit about review to help remind you of the things you need to do. I would highly recommend ScienceGeek.net as a way to review. He's got some great interactive quizzes. So we're cruising right along. I don't see any questions yet. So I don't know actually how many of you there might be watching right now. So I'm just going to go ahead and start reviewing. And as you guys come in, type questions. Oh, and I wore a shirt in honor. Science is fun. In honor of the fact that we're having this. Okay, so I'm going to share my bamboo sheet. All right. And the first essential skill. Okay. Wait, how thick is my pen? There we go. All right, so Chem, Unit 3, just called Essential Skills. So the first one is definition of a mole. And so the first thing you need to do is, of course, just memorize this, right? It's in your notes, and we took the essential skill quiz. And if you're a Silver Day person, you haven't had it yet, but all you have to do is just straight up memorize that definition, right? And then you can pass it on the essential skill quiz, your insurance quiz, and you're good to go. But on the test, it is a multiple choice question. So you have to be prepared for, we're not going to give it to you like, oh, which one's the definition? Because that's pretty easy to be able to identify that. And it's mostly, you're looking for anything that's talking about carbon-12, right? So if you have 1 mole, right, that's equal to 6 grams of carbon-12. If I had 0.25 moles, how many grams is that of carbon-12? And you would say, oh, 0.25 times 12 would give us 1/4, which is 3 grams. Oh, 1 mole, I put down 6 grams. Ha ha. You all are probably at home going, no, foolish teacher. Sorry, 1 mole is 12 grams of carbon-12. And 0.25 moles is 3 grams of carbon-12. Yeah, I mean, you get the idea, right? It's the number of atoms or particles that are equal to the amount of atoms in 12 grams of carbon-12. That's a pretty straightforward one. We may only have 1 question for that on that essential skill. I can't remember right offhand, but usually we try to do 2 questions per essential skill. All right, the second one. The second essential skill is, let me just glance at that because I don't have it memorized. It is the moles to atoms or atoms to moles. Moles to atoms or atoms to moles. Okay, so you're going to get a question that is basically something along the lines of convert 1.5 times 10 to the 23rd atoms of calcium to moles of calcium. It's not capitalized, it's lowercase. So you know right away, using the things that we talked about, the ways that you can easily identify your bridges. Oh, look, it says moles, therefore it's a two-step bridge. So I'm going to have this bridge right here. And in the first blank is always our given, right? I'm just going to write given really small right here. So in that situation, it's the 1.5 times 10 to the 23rd atoms of calcium. Number, unit, substance, 1.5 times 10 to the 23rd atoms of calcium, right? I'm just going to, oops. Hashtag US, number, unit, substance. Okay. And so if we have atoms of calcium as our units right here, we know that diagonally down, it has to be the same unit because they have to cancel out atoms of calcium. And then, so that's what we want to cancel. And then in the top right is what we want to find. What are we trying to solve for? In this case, we want to go to moles. Moles, it's a horrible line. Moles of calcium, okay? And then what number makes those equal? What, back to the same question, what number always goes in front of moles in a conversion factor? And that is a 1. So then it's how many atoms are in 1 mole? Well, if you're starting with the times 10 to the 23rd, it's probably going to be 6.02 times 10 to the 23rd, okay? And atoms and molecules are interchangeable, okay? You plug that into your calculator and you should end up with 0.25 moles of calcium. All right, so that is one example of what you might see on the test, right? Pretty straightforward. Let's go to the next page. And as I do, let me just look back and see if anyone has posted any questions. No questions yet. All right, that's okay. We'll just keep going. All right, the next one is, so this is number 3. This is moles to grams or grams to moles. Okay, and so in this one, because we're dealing with grams, we are not using Avogadro's number. Now we're using the periodic table, okay? And let's say we had, let's do 2.0 moles of, convert 2.0 moles of magnesium to grams of magnesium. Oh, why didn't I just use the symbol there? Okay, so it might also say how much does 2.0 moles of magnesium weigh? All right. So whenever you see weigh, you know they're talking about mass. Weigh means mass. So that's going to be converting to grams. All right. So we see moles. There's moles right here. So that means it's a 2-step bridge. Okay. It's not a 3-step because moles is mentioned. All right. And if you remember, our given goes in the first blank. So that's 2.0 moles of magnesium. And we have to convert, we have to get a, we have to cancel. That's what goes in the bottom of the next step. And so that's going to be moles of magnesium. And we're trying to convert to what we want, goes in the top right, which is grams of magnesium. What number always goes with moles? That's right, kids. It's 1. Actually, a student told me today that sometimes when I do these, because there's nobody actually talking to me, it sounds like I'm doing one of like the Dora Explorer Dora Explorer or whatever shows, which I think is pretty funny. So when I'm asking questions, and all of you at home, I'm sure, are saying to your computers, "It's 1, Mr. Werner," or maybe not. Okay, how many grams are in 1 mole of magnesium? We look at our periodic table, and it will tell us 24.31. I think that's right. And so then 2 times 24.31, and our answer will be 48.62 grams of magnesium. Yay! Number, unit, substance. Number, unit, substance. Number, unit, substance. Good job. Way to go, team. All right, I'm looking and I still don't see any questions. So number 4. This one is the atoms to grams or grams to atoms. All right. So, well enough. So if I give a question like, how much does 1.2 times 10 to the 24th, oh, you can't even tell what that says. The handwriting is so bad. 1.2 times 10 to the 24th. I'm sorry, guys. That's really just bugging me. 24th molecules of, we're going to do, how much does 1.2 times 10 to the 24th molecules of fluorine gas weigh? All right. And so moles are not mentioned anywhere in the problem. So we know it's going to be a 3-step. Try to make this really long. And plus I've used the word molecules, which is awful. Okay, so it's a 3-step. Okay, and what do we know about 3 steps? Well, oh, which reminds me, we can always put this over 1, okay? 3-step, we know that the top middle is going to be 1 mole, and the bottom right is going to be 1 mole, and we know that the substance is F2, F2. We know that our given goes in the first blank. So our given is 1.2, times 10 to the 24th. Oops, I'm trying to get the eraser here. All right, 1.2 times 10 to the 24th molecules. I'm going to abbreviate a little bit, MOLEC, F2. And then what we want to cancel is down here. So 1.2 times 10 to the 24th MOLEC F2. And then what we're trying to find, what are we trying to find? When it says weigh, what do we know that the units are going to be? That's right, it's going to be grams, grams of F2. And so it's 2 fluorines together. And the mass of fluorine is 19.00, which means that it is 38.00 grams. So once I plug this into my calculator, oops, I'm sorry. I made a huge mistake in the bottom, and I hope that you guys saw that. I was just copying the same number down. The question is, how many molecules are in 1 mole of F2? 6.02 times 10 to the 23rd. Totally botched that one. My apologies. Got to put that in the bottom middle. I don't mess that up like I did. Fortunately, I saw that right now, but you get the general idea. Okay, so we plug it into our calculator. And the reason I picked this one is because I want you guys to practice using your calculators, especially one you're going to use on the test. When you have to divide by Avogadro's number, you know it's messed up if you get, you can test it out because it's going to be hard. Maybe you need to use parentheses. So I plug it in, 1.2 second function EE 24 times 38 divided by 6.02 second function EE 23, and I get a whopping, let's see, I get a whopping, oh, it's got 2 sig figs. My calculator says 75.747. I only have 2 sig figs, so my answer is really 76 grams of F2. So I hope that you got the same answer. If you did, you got it correct. And I hope that all of these essential skills you're getting correct. Number, unit, substance. All right, so those are the essential skills. Still no questions from the audience, from you guys. That's okay. I'm just going to keep on moving. We're going to go ahead and do the lab review now. Let's go and go to the next page. Okay. Lab review. Okay. So basically, let's just say the numbers that we're going to give you. We're going to say there is a hydrate. Here's an example. A hydrate of magnesium carbonate, MgCO3. Okay. And so what we want to know is how many waters, how many H2O bond to each molecule of MgCO3, okay? So what I'm gonna do is I'm gonna lay out the steps. We're gonna do it for MgCO3. Then I'm going to give you one more molecule, give you the numbers, and then just give you the final answer, and you can see if you've solved it correctly. So the first step, or actually I should give you the numbers first so you'll know, okay? So you have, so let's say that we say that the mass of the hydrate plus glass, which is like test tube and beaker. Okay, that's equal to 195.67. And so the hydrate means that it is before heating it. It's got the water in it. That's what that means, okay? And then the mass of the anhydrate plus the glass, so this is after heating, okay, is equal to 187.58, 187.58. And these are both in grams, okay? So first step, step one is find the mass. Oh, you know what else you need? Okay, you probably need the mass of the glass, sorry. And then the last thing you need is, we'll give you the mass of the glass. And that one we're gonna say is 180.00 grams. I just think that would make it a lot easier if we, we'll just make it a nice even number, okay? It won't be this even, but we're doing this for examples because I think it would be very helpful to you guys, okay? All right, so, sorry, step one is the mass of the water lost, okay? And we'll just call these, we'll call them, you know, these could be in different orders, so we'll just say mass of water lost. So that means what that is it's the hydrate minus the anhydrate, okay? The before minus the after. Okay, so you have to subtract those two to get the to get, so that's before heating and after heating, okay? That's the first step, okay? Then your second step is going to be convert grams to moles of water, okay? And you know what just occurred to me? Did I not? I thought I had a copy of the lab somewhere around here. I don't see it. Bear with me just one moment, please. I wanted to be looking at it while I was talking about this, and I thought I had it out, and I don't. So just take me 1 second. I still don't have any questions. I would love it if I were answering questions for you guys. That would be really good. Okay. All right. We got this. All right. Converting grams. So this is, I'm kind of following along the lines of the lab, what you did in the lab. So you kept the mass of the water loss, the hydrate minus the anhydrate, the before minus the after. Your second one is you're converting grams to moles of water, all right? Which you're basically setting up a bridge, and you have your grams of water, and you have 18.02 grams in the bottom of water. These are both water, with 1 mole of H2O on top. And that would end up equaling however many moles of water, okay? Your third step is you're now calculating the mass of the anhydrate. Mass of the anhydrate. Okay, so you're just calculating the mass of the salt after. The salt after. To do that, okay, you have to take the anhydrate and, oops, I misspelled it. I don't know if any of you caught that. Probably not. Okay, I'm getting the, all right, the anhydrate minus the glass, okay? The mass after heating minus the glass, okay? So that's your mass of just the anhydrate. After you do that, step 4 would be to calculate the moles. You want moles of anhydrate, okay? So it's a 2-step bridge. Again, these are the, once you do it, you're converting, you've got the grams of the anhydrate, so grams of whatever your salt is, and you're gonna put the molar mass in grams of the salt on bottom, 1 mole, because that's what you're trying to find on top. That gives you your moles of your salt. Okay, good. Now, after you have, let's see, once you have your moles of water and your moles of salt, the 5th step is going to be, we want the mole ratio. Okay, if you're following along in your lab, all I'm doing is doing the exact same thing that we had you do for the lab. Okay, these are the exact same, the only thing I haven't done is the mass of the hydrate, which is fine. So mole ratio, and the mole ratio is a fraction. Mole ratio as fraction. Okay, so we're gonna have moles of H2O on top, because that number is going to be larger than the moles of the salt. Okay, when you do that, so it's going to be a larger number. And then step 6 is round to the nearest whole number. Okay, all I've done is rewrite the same questions that were on the lab. Hopefully you guys are following along. Round to nearest, oops, and you're following along on this so that you'll be able to do this. We're going to do that. We're going to do the exact same 6 steps. Round to the nearest whole number. Okay. Okay, this is the lab. We're just doing lab. So let me give you a different salt then. Okay. So for this one, we're going to do, I think I already said what we were going to do, didn't I? Magnesium carbonate. So from the magnesium carbonate, and so if we go back for a second, so we had, it said for step 1, it's the before minus the after. So 195.67 minus 187.58. So step number 1, and this is dot however many H2Os we have here. That's what the N represents. Number of H2Os. All right. So number 1, we have to do 195.67 grams minus, and you guys need to show your work for every step for Pete's sake. It's going to be super irritating because I won't be able to give you any points if you don't show the bridges where they're supposed to be bridges and show the calculations correctly. Okay. All right. If we subtract these two, 195.67 minus 187.58, I get 8.09. So 8.09 grams. Okay. And number 1 was just finding and that was the mass of water, because that was the mass of water lost. So step 2, we're converting grams to moles. So I set up my bridge, and I've got 8.09 grams of water. And I look back at step 2 on the other page, and it said that I need to put the grams here and the 18.02 grams of water on the bottom under 1 mole of water. So 18.02 grams of water on the bottom, 1 mole of water on top, and that will give me, see that, number 18.02. And by the way, that 18.02 comes from adding up 1 oxygen and 2 hydrogens, right? That's 1.01 plus 1.01 plus 16.00. That's 18.02. I'm sorry if I didn't explain that part. Okay, so I have 0.449 moles of water. Good. Step number 3, I'm getting the mass of the anhydrate. To do that, I have to subtract the glass from the after heating. So 187.58 minus 180.00 gives me 7.58 grams of MgCO3. All right. Let's go to the next page for 4. Now we're converting it to moles, number 4. So we have, I've already forgotten what that number was, 7.58. All right. So we had 7.58 grams of MgCO3. And the, we have to, oh, I didn't do the math. Okay, so then magnesium is 24.31 plus carbon, 12.01, plus 3 oxygens, 3 times 16, and I get 84.32. 84.32 grams of MgCO3, and that's under 1 mole of MgCO3. And look, I did number unit substance for every single step in the bridge. All right, and that's going to be equal to 7.58 divided by 0.08899 moles of MgCO3. Okay, good. Now, step 5 is making the ratio, okay? Just like it says in your lab, just like I put up here, the mole ratio is a fraction of moles of water on top. 0.449 is your moles of water on top. So I have 0.449 moles of H2O on top. I have 0.0899 moles of MgCO3 on bottom. And that will, let's see, 0.449 divided by 0.0899. I get 4.9944, which is basically equal to 5/1. So 5 moles of H2O to 1 mole of MgCO3. So the answer to number 6 is 5. Oops, 5. And so you could write it MgCO3 dot 5 H2O. Whee! All right, let's answer that one. Okay. Still no questions. That is quite all right. So I'm going to give you the next one. So another example. And let's do this. So mass of glass, we're going to make it 180.00 grams again. Okay. The hydrate, and it's a hydrate of lithium perchlorate, lithium Cl, that's lithium, chlorine, and then 4 oxygens. Lithium, chlorine, and 4 oxygens. And so there's some number of H2Os attached to this, okay? If you add all that together, so the glass and the hydrate, glass plus hydrate, that's equal to, we'll say 187.21 grams. So 187.21 grams. And so this is the glass plus anhydrate. Is equal to 184.78 grams. Okay, remember the anhydrate is after, and the hydrate is before. Okay, so hopefully that helps you. So you have 3 masses there, 180 grams. That's the mass of just the glass. The 187.21 grams, that's the mass of the lithium perchlorate plus the water. And then at the end, after all the heating, the anhydrate is 184.78 grams. Okay, so you need to plug it in and do those 6 steps. If you're watching this recording and you are able to, I would tell you to just pause it right now. Go through all the steps, solve it, and then start the video again because I'm about to write the answer. If you're watching it live right now, I'm going to, of course, show you the answer. And what I would suggest is you go back later and try to do the problem to see if you've done it right. So the answer is actually lithium perchlorate dot 3. Oops. How did that happen? Okay, dot 3 H2O. Your final answer should be 3. That should be what you should get for number 6, the rounded whole number. All right. So that takes us through, now we've covered all the essential skills, and we have covered the lab question, which is the free response, which is always a pain for everyone. If you're smart enough to watch this and go through it, or what I should say is if you are, it's not about being smart, it's about working hard. If you're working hard and doing this right now, you will do just fine on that and will do well. All right. So, so basically a lot of the questions are related to the essential skills. You know, you're converting and you are converting grams to moles or moles to grams. You're converting atoms to moles, moles to atoms, or you're converting mole or grams to atoms or molecules or atoms to grams. There's a couple things that I think that you guys will struggle with. So I'm going to do a couple more of those since nobody's asked any questions yet. Let's see. Okay. So I remember now. So we're doing prefixes. So let's say we're talking about grams. Okay, we won't do this very often, but so we have grams. Okay, it's kind of your base unit. We'll call it the base unit that everything goes around. And remember that kilo is the largest. It's the largest. Okay, it's 1,000 times greater. Okay, so kilo, so kilogram. Okay, then on the test, the next one that you would have to deal with is just gram. That's just your one. I mean, it's just let's say it's just your base unit. So there is no prefix. No worries. Then the next prefix is centi. So if you had centigram, which we don't use very often, but centi is 100 times smaller. Okay, and then milligram, which is used frequently. I'll write these out here. Centi, milligram is used a ton in chemistry. I feel like I'm running out of room to write. Oops. Is 1,000 times smaller. Okay, so when you're doing the conversions, you have to remember that kilo is the only one that's bigger. Kilogram, kilometer, whatever it is, it's bigger. Okay, centi, like century, it's 100 times smaller. Milli, like millennium, is 100 times or 1,000 times smaller. And so there'll be conversions like if I said 0.100 kilograms to grams, what will the answer be? These are bridges. These metric conversions are the same. They're bridges just like the other bridges. We just haven't done them in a long time. Okay. And so you're going to a base unit. If you're going to the base unit, it's only a two-step bridge. Okay. Remember what we're given goes in the first blank. 0.100 kilograms. Okay, what we want goes over here, grams. Now, this is where inequality comes in really handy. If you can't remember, oh, and I forgot, you put kilograms on bottom because that's when you want to cancel. You've got kilograms to grams. So you set up your equality if you're struggling, and you're like, okay, which one's bigger? Kilograms or grams? Oh, kilograms is bigger. It gets the 1. How many grams are in a kilogram? Kilo. Kilo means 1,000 times larger. So that means it's 1,000 grams in a kilogram. So 1,000 here, 1 kilogram here. When I multiply those together, 1,000 times 0.100, I get 100 grams. Okay? Because the kilograms cancel out. I would, if you are struggling, I mean, even if you're not, I gotta be honest with you, I almost suggest doing this all the time, you know, setting it up. Here's another example. Let's say I had 500 centimeters and I wanna go to meters, okay? So we have our equality, centimeters equals meters, and which one's bigger, meters or centimeters? Meters is obviously the base unit, okay? And which one's bigger? Well, centi is a smaller unit. Remember, the only one that's bigger is kilo, so that means meters bigger, so it gets the 1. How many centimeters are in 1 meter? I can't remember. Centi, oh, like century. Oh, like cents in a dollar. How many cents are in a dollar? 100. Okay, good. So it's going to be 100. Okay, I set up my bridge. Whatever I'm given goes in the first blank, 500 centimeters. I've got to have the same unit down here. It's got to cancel out centimeters down there. I want meters. Put that right here. I've already established my equality, 1 over 100. So how many meters is 500 centimeters? 500 divided by 100 is 5 meters. All right. The one that's the most fun is converting between, let's say you could do from millimeters to kilometers or centimeters to kilometers. Yeah, you know, you've got a situation where you have 3 steps because you have to go through the base unit, okay? So let's say that just for fun, we want to go from, we have 25 millimeters, we want to go to kilometers. Okay, there's a base unit right here. But if it's, we don't have an equality straight from millimeters to kilometers, so we're going to have to do 2 equalities, and they both have to go through the base unit. So millimeters, I didn't give myself enough room. Okay, millimeters equals kilometers, and I did it anyhow. Millimeters equals meters, and kilometers equals meters. All right, so millimeters and meters, which one's bigger? Well, milli means 1,000 times smaller, so it's not the bigger one. 1 is the bigger one, and I kind of gave it away. I was going to make you guys guess. 1,000 millimeters. Which one's bigger, kilometer or meter? Kilometer. So kilometer gets the 1, and how many meters are in a kilometer? Kilo means 1,000 times greater, so 1,000 meters in 1 kilometer. All right, let's build our bridge. It's a 3-step bridge with our 2 equalities. And the first step of the bridge is our 25 millimeters. And I keep forgetting to put it over 1 because I want to occupy all the spaces. So 25 millimeters over 1. Okay. The same unit has to go down the next step below because we've got to cancel it out. So millimeters is going to go down here, and we're going through our base unit. So meters is in the center top. Bottom of the next step is the same unit to cancel. So the meters will cancel out, right? And we're trying to find kilometers. Okay, so what numbers do I put here that will make these equal? So how many millimeters? We already have right here. So 1 meter and 1,000 millimeters. 1 kilometer and 1,000 meters. Okay, so I'm going to plug this into my calculator. 25 divided by 1,000 divided by 1,000, and my calculator says that the answer is 0. I'm going to write the long way first. 0, 0. 1, 2. Wait, 1, 2, 3, 4. No, that's not right. I went too far. 2, 5. Okay? And that's what my calculator spits out. That many kilometers. And of course, I would ask you to put this in scientific notation. And to put it in scientific notation, it's less than 1. So it's going to be a times 10 to the negative something. How many sig figs does this have? 2. 1, 2. So we want our number to be 2.5 because the decimal point is going to go after the first sig fig. So 2.5. And then times 10 to the negative what? What is this number going to be over here? So how many places do I have to move the decimal place to get it right after the 2? 1, 2, 3, 4, 5. 10 to the negative 5th kilometers. All right. And that's our answer. Very, very fun. Okay. So that's the metric. Make sure you've got to get those prefixes down. You have to get the prefixes down. I'm trying to think of something else regular before I start doing a review. I'll spend the last like 10 or 15 minutes trying to review a little bit over material that is going to be in the review section, right? And that's going to be, gosh, it could be almost a fourth of the test, like 25% of the test. I think we try to do 20 to 25% is review questions. So it's going to be really important that you get those. All right, so the last thing I just want to say, just to remind you guys, converting, right? Ratios, And the one that's most important that relates to the essential skills is 1 mole equals 6.02 times 10 to the 23rd atoms or molecules. Either one, because they're interchangeable for our purposes right now. And the other one is 1 mole equals the molar mass in grams. Okay, so whatever substance you're looking for. And so questions could be, when do you use this conversion factor? Uh, 1/6.02 times 10 to the 23rd atoms over 1 mole. When do you do that? When trying to solve for atoms. When do you use 1 mole over molar mass in grams? Another way that it could be said is that you are converting grams to moles. Okay? So those are conversion factors that come from the equalities. All this that we've just covered, it can be very valuable doing the mixed review. Okay? Oh, you know what? One more thing I actually want to mention as it relates to the counting by weighing activity. Weighing activity, okay. So this is the part that a lot of people get messed up, is that, and I actually don't have it in front of me right now. So I'm just going to make up something entirely different. This is not the answer, but let's say, hold on. I should have thought this through a little bit ahead of time. My apologies. Okay, so the counting by weighing activity, and you did this, and so you were given a problem, and it said, oh, you have 0.44 grams of a substance. You massed it out, and that's what you had, okay? Mass on a scale. And so it said 0.44 grams, okay? And so then it would say, okay, it would say you also have, so not also, that makes it sound kind of nice. This is, wow, my handwriting is terrible on this. This is 0.0367 moles. This mass is 0.0367 moles of the same substance. Okay, and so what's the identity? What is it? So the key here is that you have to know the units for molar mass. Molar, oh my gosh, that was a weird looking letter. Molar mass is grams over mole. That are the units. I'm sorry, those are the units. These are the units for molar mass, which means that all you have to do is take the grams and divide it by the moles. Oops. Okay, which means you've got 0.44 grams divided by 0.0367 moles. And what is that equal to? So if I plug it in, 0.44 divided by 367, and my calculator spits out a number of 11.99 grams per mole. So then I go to the periodic table and I try to find an element really close to 11.99. And judging by my calculator, that substance would be carbon. Okay, the carbon. So the carbon is 12.01, which is close enough. So carbon is the answer, right? That's how you solve that kind of by weighing. There will be a problem just like it on the test. And I want you guys to be prepared for that. So hopefully you'll remember this. Okay, let's go back and now let's do some review. We've got how many minutes left? About 10 minutes left. Reviewing the things that are very important from previous units. And when reviewing, you want to review the things that are the essential skills, okay? So we want to remember things like Rutherford's experiment. And what did we learn from Rutherford's experiment, right? This was the gold foil experiment. We learned where the mass of the atom is, and we learned where the volume of the atom is, because they shot alpha particles at gold foil, and most of them went straight through. A small few, very few, deflected off, which told us that the mass of the atom was in the nucleus, and that the volume of the atom, which was massive, huge volume, stretched way out there, because most of those alpha particles went straight through, the volume is mostly in the electron cloud. All right? From this, we also learned, as a side note, that the nucleus not only is dense, but it is also positively charged. Okay, so that's important to remember. That's how we roll in these things, right? Okay. Oops. All right. What else do we do? Oh, why don't I pull up a periodic table and show it to you guys. Where's my mouse? Okay. No, that's not it. Why am I having a hard time with this? This, and what I'm about to review is going to combine a few things in there. Is this a good periodic table? Yeah, I think this one will be good. It's got too much on it. Never mind. Sorry, this is taking me too long, isn't it? Sorry to irritate you all with the length of time it's taking me to figure this out. Oh, good grief, Charlie Brown. Oh, here we go. I like it. This is too funny. This is perfect, actually. I think you guys are going to love this. All right. Where is my... So I'm going to share the picture of the periodic table. Isn't that fun? Yeah. Okay, let me see if I can make it a little bit bigger for you. Is that big enough? Is that coming through big? Yes, good. All right. So I want you to notice a few things. The first thing is, this is the same periodic table you guys use. So looking at it, if we ask you for an element and we say, hey, you know, which element is has the atomic number 5? You'd say, oh, atomic number? Look at your key right here and say, oh, that's boron. Then we'd say, well, how many valence electrons does it have? And you need to remember that it's whatever numbers with the A. Ignore all the B's, ignore the transition metals, ignore those at the very bottom. It's whatever's with the A. So if I said, how many valence electrons does boron have? You'd say, oh, that's 3, because it's 3A. If I said, how many just regular electrons does boron have? You would say 5. Just, it has 5 electrons because it's a neutral atom on the periodic table. That's the number of protons it has, which is 5. And so that's the number of electrons it has. If I said, oh, how many neutrons does it have? You'd look down and say, okay, this is its atomic mass. I'm going to round that number to 11 because that's where it's closest to. 11 minus 5 is 6. Okay. Another question I might ask you is, okay, here we have boron, and I'd say, what charge will it have? Okay. If it has 3 valence electrons, and you remember that the carbon's column is kind of the midpoint. Everything below carbon rounds down. Everything above carbon rounds up. If I said, what would the charge be on boron? What ion will it form? You'd say, okay, it has 3. So is it going to lose 3 or gain 5 to get to 8? It's going to lose 3. If it loses 3 negatives, if you lose negatives, you become more positive. So it's going to be a positive 3 charge. Boron will be a positive 3. Okay, that's how you find that out. Well, is that a cation or is that an anion? If it's positive, remember, cats have paws. Well, so that means that boron will be a cation. It will be a positive 3. It will lose 3 electrons. Okay? If I said to you, oh, what about fluorine? Is it going to gain or lose electrons? You look over here and say, oh my gosh, it's way above 4. It's going to round up. It only needs 1 more to become stable to fulfill the octet rule. So it's going to gain 1 electron. If it gains an electron, electrons are negative. It's -1. Okay. So, and is that a cation or an anion? It is an anion. It's definitely not positive. So it's an anion. Okay. So hopefully that is starting to jog your memory in that area. We also remember families are in there. And I said, okay, so F, fluorine, is in which family? This second to last column are the halogens. It just so happened that it says it right here, which is fine. This is not super, you're not going to get right this legend on your periodic table, but it helps right now. So halogen, boron, what family is boron in? Okay, don't look at the key over here. Boron, see, here's that darker line right here. It's one of the metalloids. It's a metalloid, all right? So that's the name we give those that touch where both sides of the square, both sides of that element touch the line, then it is a metalloid. So boron, silicon, germanium, arsenic, antimony, and tellurium. We are not going to include polonium, acetine, and aluminum, which is fine. All right, so that's in there. I would say this. You need to go back, and all I'm going to say is that I'm not going to go through it. I'm going to draw a picture of it for you. A very bad picture, granted. You are going to need to go back and review this graph. So, atomic number increases moving this way on the graph. Ionization energy is going up here, okay? And there are going to be, on your graph, is going to be this right here. So I'm not very good at that's horrible. Horrible picture. This is all I'm going to do. I'm going to draw this graph, and this should kind of look familiar. Okay, and maybe these are all the A family, and these are all the B families right here, C's, And maybe these are the D families, okay? And from that, you need to make some determinations. Ionization energy is increasing as atomic number is increasing. What does that tell you? I'll give you this much of a hint. This is a period. That is a period. That is a period. So there are 3 periods here. Okay, I'm not going to totally give this away because I'm putting this question on every single test. If you have questions, come in and see me, talk to me about this, and we'll go through it. All right, hey, we have a question. This is very exciting. So Ree asked a question. Okay, so Ree, your question is, what about the orbitals and things in Unit 2? When we review the things that are, the review questions are just on essential skills. Okay, so orbitals were not an essential skill, so we will not, there will not be a question about orbitals in the review section of the test. All right. You would need to know things like how many valence electrons or how many energy levels there are, how many protons, electrons, and neutrons. You don't have to do an electron configuration though, okay? Again, not an essential skill. So you do not have to go back necessarily and review that. Look at the things that are the essential skills from units 1 and 2, review those thoroughly, and those will be, that's be the content that will be in the review questions on the test. Okay. All right, that takes care of our only question for today, and it is 9 o'clock. Unless another question comes in the next 10 seconds, I'm gonna wrap this up. Are there any questions? No? No more questions? All right, well, I hope that you all learned some things and you were able to review along and this jogged your memory. And I wish you guys would ask more questions though. It is difficult to do this review and have it be something that you're gonna learn from if I don't know what you're struggling with. If you still have questions, please come in and see me in class, or I'm sorry, in school, at school, before, after school. I'm there really early. I don't stay really late. I'm only there for a half an hour after school tomorrow. Tomorrow is Club Rush, so you are welcome to come in during that time and ask me questions. And then on Friday, that's the first day of test for the blue day. Maybe you can come in before school and ask me questions. I'm fine with that. So thank you all. And oh, will there be a study guide? Sorry, yes. Sorry, there's a study guide. You just haven't had class yet, and you'll get it during class. Okay. All right. Thank you all, and have a wonderful evening.